Backpropagation method using LMS method means least square method. Here we considered the two inputs, that is x1 and x2. Let us find out the h1. How to find out the h1 value? Here we considered the two values, h1 having both net value and out value. Before this activation function we called it as the net value. After we applying the activation function we called the out value. Now h1 is equal to, here we see h1 is connected to the both inputs x1 and x2. h1 is equal to, formula here we write h1 net value is equal to x1 w1 plus x2 w2. Now what's the x1 value is 0.05, here we see, and w1 0.15, and x2 value also here, and w2 here. With this x1 x2 we considered the bias values, that b1 also considered, so we are adding with bias also. Now we can simplify this all the terms, we get the h1 net value. Here we are not applying the activation function. Now we can apply the activation function to the h1 net value. Activation function formula is h1 out is equal to 1 by 1 plus e power minus x. Here in the place of minus x we replaced with the h1 net value 0.377. Now we get the activation function. After applying the activation function we get the out value, h1 out value. Here it is the h1 out value. Here we get the net value and out value, both values. Next, how to find out the h2? Generally as like the h1 value, we are also considered the h2. The same formula is h2 is connected with the both nodes, that is x1 and x2. Now the formula is x2 into w4 plus x1 into w3. As like we are here we write this. See, h2 is equal to x1 into w3 plus x2 into w4 plus bias. Here h2 also having the bias, we can add this bias also. Now x1 value is 0.05, we placed it here 0.05, and next w3 value is 0.25, that also right here, and x2 w4 and bias as like they are mentioned in the diagram. Okay, now we can solve this the equation, we get the h2 net value because we are not applying the activation function. If we apply the activation function to the h2 net value, we get the h2 out value. Now see the h2 out value. h2 out value is equal to 1 by 1 plus e power minus x. In the place of minus x we placed the h2 net value, and we placed that h2 net value. If we simplified this we get the h2 out value. Now we get the h2 net value and h2 out value as like h1 net value and h1 out value. Now we completed the h1 and h2. Now we go with the out one. Out one is connected to the h1 and h2 nodes. See, let's see here, h2 and h1. Now we can solve this equation. Out one is equal to formula h1 into w5 plus h2 into w6. Now we write the out formula here, h1 into w5 plus h2 into w6, and this out value also having the bias b2 0.60. Now that's the b2 value also include here. Then we solved it, we get the out net value, out one net value, and we get we can apply the activation function, then we get the out of out one. Okay, now apply the activation function. 1 by 1 plus e power minus x. In the place of minus x we replace it with the net value. This net value is replaced with here, and we get the 0.7513 out of out one value. And next as like same out two value we have to find out. We completed the out one net value and out value, and output 2 having both net value and out value. Now the formula for the out 2 value is out 2 is equal to h1 into w7 plus h2 into w8 plus also having the bias value 0.60 and 0.60, and we are considered the same formula here, and then we get the net value. If we want to the out value, we can apply the activation function, then we get the out of the out value and completed here. In the place of minus s, we replace it with o2 net value and got it. Next we have to check first the out of out1 value and out of out2 value is reached to the target value or not. First, they are mentioned in the question. Out of out1 is equal to 0.01, but we have to got it the out of out1 is equal to 0.513. This both are not same, means the out of out1 is not reached the target value. In this case, we have to apply, we have to know the what's the error here. For this, we have to use the error formula. Error is equal to half of target minus output whole square. Error of out1 is equal to, first we apply the out1, we have to know the, you have to find out the out1 error, and then we go with the out2 error. First, out1 error is equal to half of target minus output whole square. What's the target of the out1? Out1 target is 0.01 and target of out2 is 0.99. First we consider 0.01 for the out1 target, and o2 is the output of out value. What's the out value? We get the output 1. Output 1, we get the output value is 0.5713. That the 0.57 we 75 we have to write here, and we get the out value, error out value, out1 error value. Out2 error, same formula we use, 0.01 instead replace it with 0.99. See, they are mentioned in the target value 0.99, that the target value we placed in the t, and minus 0 means here not 0, it's the output we get it. O2 out value, how much we get? 0.7729, that the out value is replaced here. Okay, then we get the out value. And next, error is equal to out1 plus out2, out1 plus out2. Okay, out1 error how much? This is the output error, and out2 error how much? 0 point this. If we both add here, only error means only we get the only one, means generally error formula is total error is equal to error of out1 plus error of out2. We find out the error of out1 and out2. If we add this the both errors, we get the error, total error. This is called the total error. Okay, next, here up to here we get the forward portion only, we get the error. But how to rectify this error means we using the least mean square method to rectify the error. For suppose we have to change the error, we can update the weight as w5, w6, w7, w8 or w1, w8, any one of this, and again we go with the forward. Up to here we can done the forward operation. Okay, next let's see how to update the w5 value. Okay, we know that if we update the w5, dou e by dou w5 is equal to dou e by, generally every perceptron model has seeing as like the both is x1 input, x2 input, and we get the output y. Before that we see the out value and net value. Okay, let's see what's happening here. If in the question, for suppose here we consider w5, here we consider the error value, and as per this I can write the formula. See, let's see, dou e by dou w5 is equal to dou e is as like right here, and then after error, after here the error we get na, then error after what we get? Out value, means dou e by dou out of out1 into dou out of out1 by dou out value after what we know? Net value, net dou of net out1 into dou of net out1. Same here we write it numerator, and remaining term in the equation is w5, then is right here. Okay, if we simplified this 3 equation, then we get the new weight. Okay, how we simplified this? Let's see. Dou, first we consider the first part, dou e by dou out1, dou by dou out1. We have to know the error formula. What's the error formula? Half of target minus output 1 whole square. Here carefully see, why I will consider the out1 value here instead of out2, because we are find out the w5 new value, means w5 is connected to the out1 value, so we have to find out the out1 value. So for this w5 I can consider the output 1 value. Okay, let's do the derivation to this part. Let's assume t minus out1 is the x value, and it's how it's visible, half of x square. If we apply the derivative term to this, what we get is half into x square derivative is 2x. Okay, x means target minus output 1 into 2 into target minus output 1. These two cancel, and as per the chain rule, target minus output 1 is not an x, but we considered, so again we have to derivate this part. Okay, with respect to out1, means this is a constant variable, so it becomes to the 0 minus, and out1 with respect to out1 derivative means 1, so 0 minus 1, how much we get? Minus 1. So this minus term we can place it here. Okay, next this minus term comes from target minus out1, target minus output. What's the target value? 0.01 minus out1 0.75. Out of out1, we already find the out of out1. Here we see out of out1 0.75, that the 0.75 we write here. What's the target value? Target value is mentioned in the question part. Here see target value 0.01, that the replaced with here. Okay, now we get this value. Okay, next error by out means first value we get it. Next, how to get this one out by net out 1? We find out this net out 1 by net out 1. We have one formula. If we derivative this the term with the in the out 1, we have to replace it with the sigmoid function, activation function, that is 1 by 1 plus e power minus x. If we derivative to this term, we get this formula, that is f of x into 1 minus f of x. In the f of x, what the numerator term? Out of out 1, means in the f of x term we replaced with out of out 1. The output of out 1 is out of out 1 means 0.713. We have to replace this, then we get the formula, we get the solution for this second part. And now we can go with the third part, net out 1 by w5. Let's see net out 1 by w5. Net out 1 by w5 na? Net out 1, net out 1 means formula of net out 1. Net out 1, here we see formula of net out 1. Net out 1 formula is h1 w5 plus h2 w6 plus w. The derivative this term with respect to w5. So I can derivative this term with respect to w5. Then how, what we get the h1? H1 we get, how we get this h1 is, if we derivative with respect to w5, only we get the w5 terms only. Remaining terms becomes the 0. Now the both terms becomes 0, means remaining only w5. W5 respect to w5 we get how much? h1. H1 term is right. Out of h1 value here we write. Out of h1 value means go out of h1, here we write out of h1 value 0.5932, that the value is replaced here. Okay, next dou e by dou w5. Now we get the three quantities. Out of e by out 1 target formula you get it. Okay, next out by net value from the formula f of x into 1 minus f of x we get it. And next the target term, that should be dou net out 1 by dou w5, that the term we have right here, then we get here. Now multiply the three terms values. Now 0.74 into 0.186 into 0.5944, the both three terms we are multiplying here, then we get this one. Now we are not complete the total term. As per formula, new w5 new is equal to w5 volt minus delta w. What's the delta w? Means output into input generally. For we can mention the learning rate eta. Generally the eta is called the learning rate. The learning rate should be taken in between of 0 to 1. In between 0 to 1, whatever the value we want, that we can take. Generally we can take the 0.5, so I consider the 0.5. W5 volt means the question they mentioned 0.40, that's the W5 volt value. So the W5 volt value is right here, minus eta. Eta means 0.5, already I told. Dou E by dou W5, we get the three values are multiplied here, na? That value we can replace it here. Then what's the W5 new value is, if we simplify it, W5 new value we get. That's the total problems. A complete problem of back propagation using LMS method. Once see what's the steps involved here. This is the complete problem of back propagation using least